Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Witness Day, we're going to talk about what the heck is this AV1 that everybody is talking about. So let's dive right into it. Now, what exactly is the problem that we need this new tool? Well, the reality is we are making a lot of video, as in like surprisingly lot of video, and the rate that which we are making videos, that is also going up exponentially, meaning this is from YouTube, and as in like this is like around how many hours of video uploaded per hour. So it in 2006, not bad. In 2014 it's like 300, in 2015 it's 400, 2019 500, and I'm reasonably sure at this point it's even higher than that. So you can get that point, like every hour we are uploading more hours than there is. So the amount of video that is being distributed, created around the world is going up exponentially a lot. And not only that, like if that was happening, that is one issue, but yes, our resolution is going up, our bitrate is going up, our bit depth is also going up. So every vector that is there in a video is going up, including FPS also, meaning there was a day back in the day, if you had full HD, 30 FPS, good bitrate, 8-bit, you're like, whoa, awesome. Now we don't even give a damn. At this point in time, there are actual mirrorless camera that are less than $10,000 that you can buy that can shoot 8K. And bit depth could be higher than 10-bit. So reality is that everything is going up. And in FPS, like this TV itself is capable of 120 FPS, which was unheard of back in the days. Like when Full HD came into be, if you are going to like, we're gonna have 4K at 120 FPS and I will just have it, you're like, whoa, what are you smoking, man? So reality is everything is going up. However, our bandwidth and storage, it's not scaling up proportionately, meaning there are certain limitations in laws of physics, meaning how quickly you can switch on and off a, like let's say a light signal. There is a certain physical limitation that you cannot just like, oh, we went from 10 Mbps to 100 Mbps to 1000 to 10,000 to 10, no. It's like starts to tether out, and that's why our speeds are not going up as much we thought. Like what we are actually gaining is like high speeds reaching to everyone, rather than like, you know, our high speeds becoming ludicrous speed. So there is some physical limitations in bandwidth, like there are some laws that cannot be broken. And storage, again, we really suck in storage. Like our bandwidth is at least somehow able to manage to keep up, but our storage really sucks. So reality is those two main problems, that our bandwidth is not high enough and our storage is very low, and the growth of net users, meaning the grand amount of people that are using it, is started from like, you know, 100k people, 200k people to 1 billion people to 2 billion people, and we can easily project this puppy to go to 5 billion people in the future. So users and service, they need something good and they need it fast. So what are the alternatives that we can utilize? Well, the world as of now started to, when this Blu-ray became a thing, started to utilize H.264. Now you have to understand, whenever you're talking about optical media, you're talking about a whole package deal, because when DVD was launched, it was launched as a protocol, as in like DVD disc and protocol was locked together. So you can literally run, let's say a 2020 DVD into a 1990s DVD player. That was the whole point. That's why they do not, even though right now you can buy a like, you know, very high quality digital movie at 4 GB, you will not find that in DVD, because again it has to be contained, packaged. So when they wanted to create a new format, as in like this puppy, new codex was created, which was H.264. Now be mindful, this codex got its entry, quote unquote, from this sort of devices, but that was just like, you know, starter package. And then they started to go into security camera, where they would have a hardware decoding chip, and that will, like, you know, encode the incoming footage and store it in the hard drives. Again, it's very important. Even my car's dash cam also does that. So it was very good, but its efficiency, basically how efficiently it's able to encode, compress the video footage, goes down the moment you go up from full HD to 4K. At that point in time, 4K is like, it's not that efficient, meaning there could be something done, but that is a bit better. At 4K, there are many things that are like, is it really worth it to, like, you know, save this package of data? It's like not, but like H.264 was not designed with that in mind. It was designed like, you know, for this thing, Blu-ray thing. So we created a new system. H.264 was the, like, you know, AVC. If you type basically VLC codecs, if VLC shows AVC, that simply means H.264. So we needed something that can handle higher resolutions. So we entered this puppy, that is like 4K Ultra HD stuff. So this was H.265, HEVC. Now this is the bee's knees at this point in time. It's good 4K, but nobody uses it. Now, what do you mean? Like, I have this like physical hardware that uses it. Even my TV can decode it. Is the penetration, the market penetration is the way that you judge whether this technology is successful or not. Because again, you will always find niche. Heck, there are people who are buying music in vinyl, but again, that does not have market penetration. So H.264, GG, awesome success. H.265, almost a failure. Like, even from a company's point of view, it's almost a failure. Why the heck that happened? Well, reality is the patent market is a mess. On top of that, you have to pay multiple parties. For example, there's Motion Picture Group Alliance, there is HEVC Alliance, and there is a Vilios Media Alliance, and then there is random BlackBerry comes up. Like, literally, BlackBerry actually started to do this. They went to the companies like, I see you are using H.265. I would like to my cut. It's like, what the hell? Again, the patents of an algorithm is very sloppy, meaning there are many mathematical algorithms. So every company tries to patent it, but here's the deal. You may want to improve algorithm in future. Then it's like, oh bro, that package, that updated package is from this company. And then you're like, oh, what if I'm using this core? Core was patented someone long ago from this company. So that creates a mess right now that nobody wants to pay for H.265. Like, again, if you can't do anything about, for example, like players, manufacturers who are doing this, they don't have to deal too much, because like, again, that is from Samsung. So surprisingly large amount of Blu-ray players were from Samsung, Dolby Vision. They paid for this anyway. So this creates a scenario where H.265's hardware encoding and decoding chip did not become as commonplace as it could have been. Like, for example, H.264, I can buy that in my dash cam. Try to find that in any dash cam that is cheap in H.265. No, you will not find it, simply because it did not become powerful. Same goes for security cameras. Again, these things will love, like, this sort of advanced codecs, but nobody is using it. Same goes with streaming media. They would love H.265, but nobody is using it because nobody wants to deal with this patent mess. So adoption from a mathematical point of view is almost non-negligible. So it did not did market penetration as somebody hoped. Like, again, NVIDIA would give you H.265 encoded, and it is most likely already there. But problem is, like, it's one of those things like, we can afford it, we just put it. Like, unless the service that are utilizing it is not going to use it, there is no point. So VP9 was created by YouTube, and if you type stats for nerd, there is a very good chance you are seeing VP9. Now, this is not an amazing codec by any means. It's actually a little bit inferior than H.264, but it was an open source system, because Google figured out very early on is that if every one of us tries to create our own system, all of us gonna poop the bed basically. So we have to create an open source system, almost like Linux. We had to bite our ego, and we have to just like, okay, this is an open system, everybody go YOLO on it. And that's what created this need. Basically, there is a need in the market for something like AV1, which is a open source pro level codecs, so which can actually fight or even beat H.265. So that's why, even though we have a better codecs, we don't use it, simply because the patent hell is like, no, just no. Even though, like, I have physical manifestation of it, nobody uses it. So we come to AV1. Now, AV1 is basically VP9 upgraded. VP9, they looked at it, they built it, they learned a lot from it, because it's a different thing to just like, oh, we are building something in lab. Another thing to, we are running YouTube on it. So they learned a lot of it. So they realized VP9 is a good system. It gets the job done. Not the greatest, but it gets the job done. So how do we make it better? We just add more to it. How much more? More to it. How much more you want? Yes. Like, it's a lot more. Like, if you want to go into deep dive into it, I have provided a video down below of a professor who's explaining, like, who's actually working on this sort of stuff. It's a bit old video, but be mindful, this codecs that you are seeing today has been worked on like 5 years ago. So that is to be expected. So they put a lot of transformers, quantization, blocks, everything was cranked up. And these are the three things that I even understand remotely, but they put so much of everything. Like, oh, this can be done, how about we can do more of it? So for example, this is VP9 codecs. Like, this is same, almost similar architecture that you have from H.264 to H.265. So you divide videos in blocks. Now you want blocks to be very small and very large at the same time. Why? Well, think of this way. Let's say this footage is there. These things are not changing that much. Again, there will be icon here, is fixed. So you do not want to put data on that. But here will be this is just a gray block. They want to give us very, like, large block to it. They do not want to change. Blocks are like the place where changes are happening. So some things need very large blocks, like 64-bit. pixel, some would need very small one, like for example things around my eyes, because eyes are always moving, you want to use small blocks. So this was the old design of working things. Now they're like, what if we need even larger blocks, like 1 to 8, and that's why it makes more sense in high resolution, because the part of a scene that is static in a larger resolution is much larger. So 128, they went on the upscale, and how they are subdividing it, that also changed. And this is the crucial aspect of any modern codecs. Is like, it's not just like take a video footage, slice it up. No, it's like take a footage, analyze the noise pattern in it, and then it's like where the higher noise is there, you give a smaller block there. Meaning in this area, basically around this area, there will be a lot of noise here. So what they will put is like a lot of sub blocking there, so they can absorb the detail there. But things that are not moving, basically this is Thorner is static, so they're like, okay, just give it a block. Static, give it a block. So you want like big and small. So it goes to 8 pixel by 8 pixel and big as 120 pattern. Then how do you divide it? That's a mathematical thing. You can just like simply divide it. So old design was like, you slide it vertically, horizontally, or cross slide it. Now they have the same thing, horizontal and vertical, but they have sub pattern inside it. Meaning what if bottom slice is a big one, top slice is 2 small ones. So that's how they did it in every block, meaning you can divide things surprisingly. And the higher the resolution you use, the more benefit you get from this core design of blocks transmission. Then you come to another mathematical things like quantization parameters. Instead of using 4 parameters that were available in VP9, they are using 6 parameter in AV1, and like 8 parameters per frame went up to with both spatial and temporal resolutions. It's like predictions are off the chart. The amount of prediction they put into this is bonkers. One specific thing they realized is noise. Basically every camera sensor has a noise, and every film grain has a noise, and it's one of those things that it's very hard to compress, because again, it's available uniformly everywhere. So how the heck you compress it? And if you compress it and you add it in post, everybody can tell, hey, you changed it. It's like, it's one of those things. So they literally encoded a hard-coded noise generator that literally all its job is like study the noise of the video, then paste it in the, like, create a codecs. That codecs have like data block. That data block will be read by the decoding algorithm, and decoding algorithm is like, okay, this is the noise pattern. So they can carry forward noise without changing it. So you heard people talk about like, go to Vimeo, it has like better video quality. That's why like noise, the YouTube compression algorithm destroys noise. So it becomes very artificial. Like in terms of transform, 4 transform went up to 16 transforms. Like they're just like amp it up. Like transform sizes, like how big the block, mathematical blocks can be used, is like 32 to 64. Everything just went up, everything. So a lot of benefit is there. Now, because this is almost like a consumer built equipment, like it's again, Google had a focus in mind. Twitter, I'm saying basically Instagram had a vision in mind, and so did Twitch had a vision in mind. So they focused on low bitrate quality, meaning can H.264 make good video? Yes. Can you H.265 make even better video? Absolutely. Can H.264 make a good video and H2 low bitrate? No. That's the whole thing. They were focusing on low bitrate. Why? For example, if you are a Twitch streamer, you are limited to 3500 kilobits per second. If you want to go up, you have to be a partner. Again, starter cannot have that. So they were focused on those sort of environment, whereas like low bitrate, get it working. And why would you want to do that? Again, Twitch is just one thing. Video calling also is limited by that. So if you can transmit a lot of quality in very little bitrate, everybody can do video calling. This looks good, does not look garbage. So it was the main focus, like low bitrate. And then on the upper end, that's the low bitrate one, there is upper end. Upper end is that if you have higher resolution, the bitrate that is very high, it should save a lot of space. For example, if I'm watching a Netflix movie in here, because of this 128 pixels system and all other algorithm, they can transmit very high quality movies to my TV. It will be only few gigabytes, and my TV will be able to show me to such a degree where it's like it's almost lossless compression, like for my eyes. So at high resolution, it saves a lot of space. At low resolution, low bitrate limited systems, it gives very high quality compared to H.264. However, if you compare it to the modern latest gen platform, as in like 266, which is classified as VVC, Versatile Video Codecs, it's poor. AV1 is poorer than H.266. Let that be very crystal clear. It's a competitor to H.265, but it gets its ass kicked with H.266. But there is no, like, I can't hold H.266 anymore. So let's explain why that is. Even though H.266 is better and already been fine-tuned and finalized, why the heck we don't use H.266? Even H.265, why the heck we don't use it? Same comes to the whole reality of deployment. You have a better codecs, no deny that, they're flat out. H266 is a better codecs, but nobody's gonna use it because nobody wants to deal with the cost itself and the hassle that it has with a mess of players. Meaning, so many people are working on it. It's like, I want my cut, I want this cut, I want that cut. It's like, just go away, just go away. I'm not gonna buy it. So reality is, even though we have better technology, nobody's using it. So AV1 has fast tracked simply because so many people wanted to work, like as in like the people who have like big pockets. For example, this sort of companies which include almost everything. So it got fast tracked, meaning decoding engines were built surprisingly fast. As in like the professor that I'm talking about, he was talking about that is like in like 1 to 2 years we got actual decoding software engines working. Like that was fast. And not to mention, hardware decoding was like available long ago. Like your mobile phone can actually decode AV1 directly. Like it's already had it. Many system on chip that is used in mobile phones already had it. Like that's how fast tracked it was. And hardware encoding, like decoding, we always had it. The encoding part, basically, when you have to make it, that part will be coming in 2022, and it will coming to consumer. It was already there for the server. Like it was done surprisingly fast. So Intel, AMD, NVIDIA, all are selling hardware encoding chips that will be available to us. So basically in next 2 to 3 years, more and more system will have it. That's why I specified the fact that there is no mass push for H265, H266. That's the core difference between those things versus AV1, and everyone is using AV1. Like for example, there are many camera companies that are dealing with security camera. They are saying, yeah, we want to use AV1, and given the fact that there is no patent war on it, we'll use it. So I can easily see in next 2 to 3 years, AV1 codecs will be used in my dashcam, hopefully. So that's why like a lot of things are being done at this point in time that makes the adoption rate idiotically high. And YouTube, Twitch, and Netflix all have already deployed it, meaning they have servers that are stored the file in AV1 codecs. They are deploying it in AV1 codecs. Now, most of it's not active, meaning it's more of a background testing, more of like figuring things out, analyzing, because again, not all TVs can decode AV1 directly, so they may have to use their general purpose code. So they will have a talk, like Netflix will have a talk with, let's say, LG, Sony. It's like, hey, can your chip can actually do it? If they can do it, then they will send that footage. If they cannot, it's like, okay, we understand, we'll use the old system. So, and again, deployment simply means these things are already being laid out. Basically, the fiber is already being laid down. Things been taken care of. Now, another aspect is there are some patent trolls. There always are. Like you would be surprised how many patent trolls are there that are actually trying to troll big companies, and some of them win. But here's the amount of big daddy companies that are here. For example, devices and tool development. It has Android, big enough. It has Apple, really big enough. Google, done. It has Intel, basically Windows is already there, Microsoft is already there, ARM logic is already there. So everybody is there. Then we come to apps, content and service. It has Chrome, it has Adobe, it has Amazon, it has Prime Videos, it has Hulu, it has Google Duo. That's what the example they are showing. Netflix is there, VLC is there, Twitch is there, Mozilla is there, IBM is there, YouTube is there. And in software and silicon, the physical hardware, almost everybody that you know, ARM is there, there is a Broadcom is already there, Cable Labs is already, Cisco is there, Intel is there, NVIDIA is there, SoC Con Next is there, Excel, like everybody is there, basically. Everybody is there. So meaning if somebody wants to patent troll this conglomerate, good luck. Good luck. There is a 100% chance you're going to get your ass served to you in a silver platter. So that's why this alliance for open media is a good thing. And Google Duo is already practicing it. So modern phones, there is a very good chance it may be sending footage using basically AV1, and you might not have the chip that is encoding it, but it might have a chip that can decode it. So you may be receiving AV1 while sending H264. So deployment is done surprisingly fast, meaning it's just gonna come and disappear. Like we will not think about it simply because it will become so ubiquitous. How it happened to H264. Unfortunately, it never happened to H265 because H265 did not get it act together. It's like, okay, all of us just make a pool, and again, either you do that or everybody starves. So they chose the starvation. Good luck. So deployment is really fast on this puppy. So what we can expect in the future? Well, this whole idea of creating open source codecs is a really good thing. It's almost similar to Linux. Like think of this, like how odd is that majority of world's servers run on an open source architecture known as Linux? How the heck that happened? Simply because somebody realized that no matter how big your company is, you cannot hire the best of the brightest of every single walk of life. It's not gonna work. So what they did is like, hey, we're gonna work on this. You can also help us. You can also bug fix it, and you can utilize it in your professional environment. Don't worry about it. So everybody did. NASA did it. So every Tom, Dick, and Harry who worked on it improved it little bit, little. Over time, it became so superior that every other proprietary solution was just not good enough. So everybody else also jumped into it. Then it became a self-perpetual cycle. So Linux became the backbone of entirety of world. And it's one of those models that's like no one pays but everyone wins, because again, you have to pay one way or the another. You have to pay for the chips, you have to pay for the patents. If you just like bite the bullet, it's like, okay, we're gonna work on it without any monetary reward, you're gonna get a tool that you can use without paying a boatload of money, while you saving a lot of bandwidth, while fine-tuning the codecs for your niche case. For example, Twitch literally desiring, bro, make sure that it works in 3500 kilobits per second, for that exact reason. So it will affect us all. It's a very small change, but it will affect us all. For example, from video calls that you will notice is like, whoa, video calls nowadays on the same network looks much better. Video calls, you will know, streaming, you will notice it. Media consumption, you will notice it. And again, media consumption, you may notice it in different way. For example, your Netflix downloads everything in a buffer, then dumps the buffer footage to your system. So if the buffer is slower, more people can use in Netflix and given the same network infrastructure. So it will affect us all. And free and open source will allow a lot of upgrade path. Now, what does that mean? That simply means AV1 is the slow one. So AV1 is like, I already spy, H.266 is already better. But if AV1 becomes a thing, everybody figures it out. Like, this company is going to manufacture the chip. This is the problems that we have to face with it. This thing, everything. Once we sort it out, the next variant will be done even faster. Because at that point, it's like how quickly Linux kernel keeps getting updated. Because once you sort that out, once you lay the foundation, it's done. If the foundation is good, you can keep upgrading it. So same will happen here. This whole idea of like having an open source system is really desirable for all of us. Like it's really good for all of us. So this was my presentation on AV1. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.